So the next example we're going to look at, we have 1, 2, 3, 4, 5, 6. So I have quite a few examples. The reason for that, I think working out problems and doing the examples and having something to reference as you're doing these is going to help you the most. I want to show you on this very first problem how to do the problem using the formula. This is the only one we're going to use with the formula. The rest of them will use the calculator. So this one, we're going to start off, read over the problem, focus on what is the claim. So it says here, in a survey, 1,864 people out of 2,246 randomly selected adults said that texting while driving should be illegal. Use a 0.05 significance level. Test the claim that more than 80% of adults believe that texting while driving should be illegal. And I'm actually going to do that whole thing. I think that would be better. Okay, so step one, we already know how to do. Test the claim that more than 80%. So I see a percentage that tells me I'm talking about a proportion. More than is greater than. More than 80%. And you could put 0.80 or you could just put 0.8. This is our claim. So write the word claim. Up here, this could be less than or equal to 0.8 or 0.80. But most of you are probably doing the equals here. You can do either way. Okay. So we can see here, we're talking about one proportion, one sample, and it's a proportion. So if we go back for one proportion, we have our formula right here. And your formula, like I said, is also in your formula packet. So you don't need to memorize it. And you're probably going to use a calculator anyway. You can also see when we do the calculator, we're going to do a 1-prop-z test. Okay. And I don't necessarily have this formula memorized, but I do have it written down. So I know z equals our sample proportion minus population proportion over the square root of P times Q over N. And that's going to give us our test statistic. And you'll notice here, I have the little blanks for you to fill in. Your tests, your homework, everything will be set up just like this, so you don't forget a step. It's going to help walk you through the problem, and you'll get really used to the process. Okay, so the first thing we need to do in using this formula is we need to find P hat, which is your sample proportion of successes. And success here would be the thing we're looking for, which are the people that said texting while driving should be illegal. And there were 1,864, that would be your X, out of 2,246 people. So P hat is X over N. And when I figure that out, I get 0.8299. Okay. So here I'm going to have 0.8299. And then a lot of times finding P bothers people. Students are like, well, I don't know what it is. They didn't tell me in the problem. No, they didn't. But look right here. See how we're estimating the population proportion? If you put an equal sign right there, and that just made it a little messier, didn't it? If you put an equal sign right there, it says P equals 0.80. We want P in our formula, 0.80 or 0.8. In the denominator, we're going to have the square root. P is 0.8 or 0.80. Q, remember, is 1 minus p. They're complements. So this would be 0.2. And our sample size is 2246. This is a calculator problem now. If you're somebody that's trying to put the whole thing in your calculator at once, put parentheses around the top. And when we do that, I get 3.54. So maybe pause the recording for a second. Make sure you get the same thing I get. Okay, so our test statistic, which you'll see over here, is a Z scale, 3.54. Okay, so let's picture what we have going on here. We're looking at a proportion greater than 0.8, significantly greater. So if we're going to visualize this, greater than goes over here. Okay. This is a Z scale. When we convert something to a Z, that means it's a standard normal distribution. So we have Z is 0. You could picture 1, 2, 3.54 is pretty far down there. But we don't know, is it in this critical region or not? We don't really know. We also were given that our level of significance is 0.05. So that tells me that this critical region is the highest 5%. So now that we have our test statistic, I'm going to use a different color. I don't really know if it's here or if it's here, but I do know it's 3.54. So whether it's here or here, I want to find the area to the right. So we can use the techniques from, what was it, chapter 6 and chapter 7, where we did normal, CDF. We'd start with the 3.54. Our area is going all the way to the right. So 99999, really big number. Our mean is 0 and our standard deviation is 1 because we're on a Z scale. And again, right now you're probably thinking, wow, this is a lot of work. I'm going to show you how to do it on the calculator. And you're going to appreciate, you're going to be really happy that you have your TI-83 or TI-84. So when we do that, let's see what we get. So I'm going to go to my normal CDF, and I'm not going to bring up the calculator yet. I will when we start doing the tests. 3.54999901. And look what we get. This is going to give us our p-value. And I get 2.00 times 10 to the -4th. Remember, it's a probability, so don't tell me it's 2. A few of you did that on your test. You can't have a probability higher than 1. So this would be 0.123200. So that's our p-value. And again, it's fine if you list it times 10 to the -4th. A lot of times people see it better if they write it in standard form. Just don't include the E. Okay. So this area is really tiny. If we compare it to alpha, I'm now at this step. Let me go back. If the p-value is less than alpha, reject HO. And in fact, let me write it here. If p-value less than alpha, reject HO. And this is something you may want to put on the top of your paper as you're doing your work too, so you can reference it. Our alpha in the problem was 0.05. That's alpha. This is definitely smaller than that. So we're going to reject our null hypothesis. So that means we're rejecting it. We're throwing it out. We would write our conclusion using our table. Does the original claim have an equals? No. And then we reject. So we will say there is sufficient evidence to support the claim that ... that more than 80% of adults believe in that texting with driving should be illegal. I'll paraphrase. So this would be the longer approach. I want you to see that because for some of you, that will make it click a little bit more. Most of us really like using the calculator for this. And as I said, the longer that I teach statistics, the more I find we defer to the calculator because we can do the problem so much more quickly. Okay, so I want to show you this same problem using the calculator. And what I'm going to do, I'm going to take out this little picture here. And the main thing I want you to see when you use the calculator, you need to write down what calculator function you use. A lot of times students hesitate to do that or forget to do that, or they'll tell me, you should have a line for that. You need to tell me when you go to your calculator which function you use. That's like telling me what formula you used. So because it's a one proportion, it's going to be a 1 prop Z test. And again, what's nice about that, you're used to one proportion for a confidence interval. That was a 1 prop Z interval. We're doing a hypothesis test. So now we're going to do a 1 prop Z test. Now, I'm just going to pause this for a sec while I pull the calculator up, and I'll show you how we're going to enter this in your calculator. So we're back, and I have the calculator here. Let me just clear out what we have. I wrote down our null and our alternative hypothesis statements, and we're going to do this same problem using the calculator. So when we go to use the calculator, the first thing you'll notice, we are doing a 1 prop, 1 proportion Z test. And that is important that you write that down somewhere. So we're going to find that by going to stats. You're going to move over to tests, and you're going to go all the way down until you see a 1 prop Z test. We've done the interval before. This time we're doing a confidence or a hypothesis test. 1 prop Z test. Enter. It's going to prompt you to enter some key pieces of information. And basically that formula to find the test statistic is programmed into your calculator, and the formula to find the p-value is programmed into your calculator. So as long as you enter these values correctly, it will do the number crunching for you. Just like if you're putting the numbers into a formula, you have to put them in the correct places. So the first thing it asks for is P sub 0. Think about that. That's like H sub 0. See what it says here? P equals 0.80. 0.80 or 0.8. The sub 0 will help you. That's another reason we like to put an equals here, because it's showing you, oh, P is equal to that, or P sub 0 is equal to that. Now it asks for X and N. X is your number of successes. N is your sample size. So we had to use those to find our sample proportion when we did this before. So X, if you'll recall, was the 1864 people out of 2246. The people that thought texting while driving should be illegal out of the total. So we go back over here. X is 1864. N is 2246. Now, sometimes students have a hard time with this part because they see that P sub 0. P sub 0 is the 0.8. So 0.8 is going here, 0.8 is going here, 0.8 is going here. Just choose the exact symbol that you see in H1. And this is another reason it's nice to just put an equals up here, because this is the only inequality symbol that you're seeing here, and it's a greater than. So you're going to go down, go over to the greater than, and lock it in. And again, P sub 0 is 0.8. You just told the calculator that. Now, this, I don't usually use an 84. You guys know I have an 83. This will draw a picture of it. We're just going to calculate. Okay. So it gives us our test statistic. That's this Z value. And it gives us our P value. It also gave us our sample proportion and our sample size. We want the Z, which is our test statistic. Should look pretty close to what we got before, 3.54. The calculator will take that out more places. We just rounded it when we used the formula. And typically with the test statistic, I would say go out 2 places. You guys know I'm not picky about that though. The p-value. Students sometimes will just put 1.96. Remember, this is a probability. So you want to read all the way to the end. It's 1.96 times 10 to the negative 4th. 1.96 times 10 to the negative 4th. And you may look at that and think, wait, that looks a little different than what we had. This would be 0.000196. If I rounded that to 4 places, 0.0002. So it is the same thing we got when we did it by hand. The calculator is just more precise. It's going to take it out more places. So again, this is less than alpha, so we reject HO, and we're supporting our claim. Using the calculator just makes finding the test statistic and the p-value easier. It saves you time. You still have to make the decision on what that means. Am I rejecting HO? Am I failing to reject HO? And when you write this, include the H sub 0. It helps you remember. You're always rejecting or failing to reject HO. And then your conclusion is always about your claim. Okay, let me pause this. We're going to go back to the next problem, and we're going to get it all set up, and then we'll do the calculator again. Okay, so we're back. We're looking at the next example, and I just want to reassure you, it's common when you first start doing these, as I keep telling you, for it to be a little overwhelming. There's a lot of steps. The more you practice, the repetition with the practice, the asking questions and getting comfortable with it, you're going to get more comfortable with these than you expect. And we're doing this from this point in time to the end of the class. So this is just the beginning. The process is going to be the same. We're just going to learn some different tests about some different parameters in the population. Okay, so let's look at this study. 11,000 car crashes. It was found that 5,720 of them occurred within 5 miles of home. Use a 0.01 significance level to test the claim that more than 50% of car crashes occur within 5 miles of home. Okay, I got a funny story for you here. And sometimes I feel a little guilty sharing it, but it is kind of funny. A friend of mine, her mother-in-law had heard this, and you've probably heard it too. It's pretty common for car crashes to occur close to home. So her mother-in-law, when her kids were little, you had to wear your car seat when you were close to, or your seatbelt when you were close to home. But when you got farther from home, it was okay to take it off, which is kind of an interesting extension of that. If you think about it, though, here's your home, 5 miles from home. Every time you leave, every time you come back, you're driving in that area more often, which is probably part of why that's happening. Okay, my little story's over. We will now get to it. Test the claim that more than 50%. So we can see we're talking about a percent, which we're going to write as a proportion, more than, greater than, proportion greater than 0.5 or 0.50, either one. That's your claim. And that one would be equal to 0.5. They could have used the word majority instead of more than 50%. So we have one proportion. We're going to do a 1 prop z test. And we're going to use that test to get our test statistic and our p-value. As long as we're here, let's just remind ourselves, this is a 0.01 significance level. So you can write over here, alpha equals 0.01. What that's telling us is we're not talking about the highest 5%. This time we're talking about the highest 1%. So if we were going to look at our critical region, it would be this highest 1%. So it has to be even more significantly high. Okay. So let's go to the calculator. Pause for a sec like I usually do here. Okay, so we're going to do our 1 prop z test. So we go over to tests, down to 1 prop z test, enter. Now this time, remember our p sub 0 comes from our null hypothesis. P equals 0.5. So we'll have our 0.5 here. X and N are in the problem. So this one says 5,720 would be your X, and your N is your sample size. As I mentioned, if you get these switched, you'll get an error. And sometimes students will say, I don't know why it's giving me an error. Well, your sample size cannot be smaller than your number of successes. So sample size is always going to be larger. Our symbol, again, is a greater than. That's already chosen. I'm going to go to calculate. And here's what we have. Our test statistic is a z, and it's 4.20 if I round it. And again, don't agonize about the rounding. The p-value, once again, is really tiny. You will see that happen a lot. And actually, you want small p-values because that means the test statistic is in the critical region. And that means that you're going to support your claim in most cases. So this would be 1.36 times 10 to the negative 5th. You can leave it like that, or you can write 0.1234136. Think about it. If we rounded that, that would be 0. That'd be a really, really tiny p-value. So that's telling us it's pretty significant. It's definitely less than 0.01. And you remember our level of significance, which was given to us in this problem, was 0.01. So because the p-value is less than alpha, we're going to reject HO. Reject it. Throw it out. Which means we're going with our claim. It does look like the proportion of car crashes within 5 miles of home is significantly higher than 0.5. Now we need to write our conclusion. And we would say there is sufficient evidence to support the claim that, and I'm just paraphrasing because that takes a long time to write, supports the claim that, and then I just go look at the words in the problem, more than 50% of car crashes occur within 5 miles of home. Ta-da! We got it. And hopefully you're getting it. Hopefully this is making sense. Again, as you're working, remember office hours, math lab, those are all ways you can get support. When you do your online work, there's extra videos. There's, you can send me an email through My Open Math, and you can continue to try the problems for the mastery element. Okay, let's look at the next one. You know what? This is going to bother me that I didn't write these in. Test statistic on that one was 4.20. P-value was 1.36 times 10 to the negative fifth, which was less than our alpha. So we have a reject. And we said it supports the claim that the proportion is greater than 50%. Okay. This one has something a little bit different going on in it, and I wanted to make sure to give you one like this. So read it over, and we're going to get the claim. Gallup poll, 1,018 adults, 22% smoked cigarettes in the last week. Use a 0.05 significance level to test the claim that less than 25% of adults have smoked within the last week or past week. So less than 25%. So the proportion is less than 0.25. And that's our claim. So this one's going to be an equal. And again, we're trying to decide, well, which one is happening? Is the proportion less than 0.25? And not a little less than 0.25, significantly less. How significantly less? It has to be in the bottom 5%. So I'm going to remind myself here, alpha equals 0.05. One proportion. So this is a 1 prop Z test. Okay. So we're going to move over to the calculator again, because this one has something a little bit different going on in it. All right, we're back to the calculator, and I summarized what we had written so far for this problem. So we go to our 1 prop Z test, and what's nice is it does prompt us what we need to enter. So again, our P sub 0 is 0.25, and then we need our number of successes. And when we read this problem, all we know is that 22% of the 1,018 adults smoked. They didn't tell us what the X was. They told us what the sample proportion is. So there's 2 ways you can do it. You have P hat equals X over N. So 0.22 equals X over 1,018. And then when you solve that, you'll do 1,018 times 0.22. The easiest way, though, we want to know how many adults smoked, right? How many adults smoked out of the 1,018 in the sample? So you're going to do 22% of 1,018. We would know how many people we're talking about. 0.22 times 1,018, which is what that came out to be. And if we do that, 0.22 times 1,018, whoops, you're going to get 223.96. Okay. Let's do something just to show you. So if I put 223.96, I want you to realize something. X is your number of successes. You can't have a partial success. If you think about it in terms of people, they either smoked or they did not smoke. So this number needs to be rounded, and you're going to do normal rounding on this, which sometimes bothers students. The way I think of it is this. They got the 22% by counting the number of people. They probably rounded to get the 22%, so you don't want to double round. Let me show you something else that's kind of cool. See that 23.96? You could figure it out by hand over here. Or, let me show you this. This is pretty cool. You can do 0.22 times 1018 right there in your calculator screen. So you don't have to exit this screen. There's the 223.96. That's going to round up to 224. We know we're talking about 1,018 adults. And then this symbol this time is a less than symbol. So we're going to move over to the less than, enter to lock it in, and then go down to calculate. You can see we get a negative z. And sometimes students wonder, well, can we have a negative z? Z's not a probability. And if we remember, our critical value or our critical region was down here. So if this is 0, it would make sense that the z's on this side are negative. Our p-value, if we look right here, sorry about the phone, 0.0136. 0.0136. Oh, our alpha was 0.05, huh? I wrote that down wrong. So if we compare this to 0.05, it is less than. So again, we're going to reject HO. If we reject HO, then we are supporting our claim. So I would say supports the claim that less than 25% have smoked. In the last week. Okay. The fact that I had written that down as 0.01, I want to point out to you the level of significance. If alpha was 0.01, so let's say this was a 0.01, we would get a different result, right? Because it is significantly less, it's in the bottom 5%. It isn't in the bottom 1%. So the choice of your level of significance can make a big difference as far as your result. Typically in the medical field, medical studies, or studies where we really want to make sure of our results, we want our results to be very statistically significant, you usually use a level of significance of 0.01. Otherwise, it's more common if a level of significance is not chosen, use 0.05. Okay. So this one, this type tends to bother students a little bit. Remember, X is the number of successes. It cannot be a decimal. So do normal rounding to find that. And just watch out for that because they do tend to be a little trickier. Okay, let me pause. Okay, so let me just write those values in case you didn't transfer them over. I like to have it all in here. and this was 0.0130, which was less than 0.05, and so we did our reject. And we said it supports the claim. So again, there's a lot of steps to these. You're going to get real comfortable with them. You already know this part. The calculator part is new, and these two steps are new. Figuring out reject, and then we know how to write the claim. So these numbers, getting those from the calculator isn't too bad, but you have to make that decision on whether you're rejecting or failing to reject.